Hi, this is Dr. Allen. We're going to talk a little bit about the functions of the integumentary system in this lesson. As stated before, there's going to be some overlap with previous lessons, and that's intentional. Repetition is oftentimes good for learning things. So let's go ahead and get started. These are the objectives for today. Talk about the functions of the integumentary. We're going to dive a little bit more deeper into the apocrine and eccrine glands. We're going to talk about vitamin D synthesis. And then we'll finish up with some discussions on colorations of skin and how that could either be normal or abnormal. So here are the four functions of the integumentary system. It could be lumped together as either protection, thermoregulation, sensation, and then vitamin D synthesis. Now when I talk about these functions here, oftentimes there's overlapping features, various things in the integumentary system that actually do that particular job. So it's not just one component of it that does it. But let's get into a little bit more detail here. So first, let's talk about protection. So when we're saying protection, essentially we're talking about protecting the organism, protecting the body, protecting the underlying structures, protecting against the systemic problems as well with homeostasis and potentially for life-threatening things. Okay, so first, protection from elements of nature, wind, water, ultraviolet light. We had mentioned previously about how, say, for example, melanin can, as is secreted from the melanocytes, help to shield the keratinocytes against damage from ultraviolet light, and thus also protect the underlying tissues as well from UV light. And then you also think about wind and water, right? So this is what allows you to kind of be immersed in water and not have your entire body, swell up filled with water, or for you to become super dehydrated like a grape dehydrates into a raisin, that sort of thing. When we're talking about protecting against water loss, as well as entrance to water, we're talking about also the keratin and the glycolipids, those substances that are secreted in the epidermis and help to coat your skin and to form that waterproof barrier. Because remember, glycolipids are hydrophobic. They repel water. Protection against abrasives. Of course, these are minor abrasives, and that's what the keratin layer of your epidermis will do. It helps protect against, little minor abrasions and some bacterial issues. Some chemicals can help protect the underlying tissue. Significant abrasives or abrasions, like say if you're in a motorcycle accident and big chunks of your skin are just wiped away because of interacting with the road, that's something different. We're talking about mild abrasions. Additionally, against these microbial invaders, you can have perspiration, certain types of sweat, and certain other secretions help to fight against microbes. And then don't forget about within the the epidermis, um, those Merkel cells, no, the dendritic cells. My apologies. See, even I forget things. So the dendritic cells or the Langerhans cells that's in the epidermis also have that antimicrobial effect and protection. All right. Another thing that can happen with the skin, the integumentary system, is thermoregulation. And what is that? Thermoregulation is just regulating your body's temperature. Your body wants it to be at a certain temperature within just a few degrees here and there. You've heard maybe 98 degrees is about normal. So you can be from 97 to 99 degrees and still be kind of in the range of normal. Once you get below that or above that range, then you're starting to have some abnormalities. But the purpose of the skin is to help keep your body at a certain temperature. So one way that it does it is through perspiration. So if you think about it, you're really hot. What do? You perspire, you sweat. And what is the purpose of doing that? Well, it's so that your body temperature can cool off through the process of evaporation. Now, without getting into the science of it too much, just the evaporation of water off of a surface will drive heat loss from that surface. Okay, so as the water evaporates, you cool down. Perhaps you've experienced that yourself. You know, you're perspiring, and then a nice cool breeze comes along, and you feel nice and cold, or at least maybe not quite so hot. It could be taken to extremes, though, right? So if it's a cold day and you get all wet and it's windy, you get a whole lot more chilled through that process, and that's just because that evaporation of that water off of your skin will drive heat loss. Okay, so with that in mind, in lab we talked about these two types of sweat glands, eccrine glands and apocrine glands. Important to notice the difference between the two. So when we're talking about thermoregulation, we're talking about the eccrine sweat glands. That's the one designated by this top arrow here, right? So this one right here, this is the eccrine sweat gland. You can see how it's this little coiled simple tube, opens up to these little pores in the skin. And you can kind of imagine that, right? So if you're starting to perspire a little bit, you get little beads of water kind of on your skin surface, and that's just because that sweat is starting to come out here. It's this particular perspiration, and when that evaporates or is exposed to wind, will cool you down. And then these other glands, these apocrine sweat glands, they really deal more with hair follicles. I mean, they would also have some thermoregulation properties to it. For example, if you ever have some perspiration under your arms because you're nervous or something, and then it's exposed to a little bit of wind, it feels a little bit chilly. But that's not what the purpose of these are. These apocrine sweat glands have a different purpose because they're actually attached to these hair follicles. But when you think in thermoregulation, think eccrine sweat glands. Eccrine sweat glands. So that's thermoregulation through perspiration and the eccrine sweat glands. Another way that your integumentary system helps with regulating your body temperature is through these blood vessels in the dermis. Okay, so you can either dilate or expand your blood vessels that will shunt blood to the surface of your skin, or you can constrict the blood vessels, which reduces the blood flow to the skin and keeps your blood more towards the core of your body. It depends on what's going on. So if you're kind of hot, right? You have a hot, you've been working out, or it's a hot day. Ever notice what happens to your skin? Sometimes it gets flush, and that's because the blood flow is being increased to your skin to allow heat to radiate out of your body. So the blood is trying to take heat away from the core of your body so it can radiate out into the environment. On the other hand, if you're in a really, really cold environment, freezing temperatures, for example, or even just maybe not freezing temperatures, just pretty cold, what happens to your skin? It starts to get a little bit pale. Your fingers might start to feel a little bit numb. Your fingers start to feel a little bit cold. Why is that? Well, that's because your body is sensing that it's pretty cold out and we need to preserve the core of the body, the brain, the heart, the kidneys, the vital organs right here in the center. So it shunts blood away from the surface and your extremities, and it keeps it into your core, and that helps to maintain body warmth. It may sacrifice your extremities in the process, but in the grand scheme of things, losing a finger due to frostbite is potentially a better solution than just dying from the cold. Does that make sense? Okay. So that's it for thermoregulation. Let's talk about sensation. In the lab, we go over these cells. We talked about these cells also in the previous lecture, but we have these four particular sensory structures here. I have them labeled A, B, C, and D. We have the Merkel cells, these tactile cells here in the epidermis at the dermal-epidermal junction. You have these Meissner or tactile corpuscles. Remember the Merkel and the Meissner cells, the Merkel and the Meissner, they have these tactile sensations. And what does that do? That's for touch. Um, and then we have these free nerve endings. So that's this one right here. And kind of follow this up. It doesn't have a little balloon or whatever out. It just kind of ends right there. And then you have these things called Pacinian corpuscles here. They're a little bit deeper in the dermis. So this is just a review as well. So the Merkel and the Meissner, they're tactile, so they're involved with touch. You can see the Meissner corpuscles do a little bit more, maybe a little pressure and vibration. But touch sensations are from these two cells, or structures, I should say. Free nerve endings, these are dendrites, they detect pain, temperature, itch, tickle, and some other things. And then these Pacinian corpuscles deeper below, they sense vibration and pressure. Then we move on to the function of vitamin D synthesis. D is in delta, or D is in dog. What is vitamin D? Well, it's a nutrient. It's a thing. It's a substance, if you will, that's necessary for your body to do certain processes. One of which is to absorb calcium and phosphate from the diet. And so, why is that important? Well, if you don't have enough calcium and phosphate, you have problems with your bone, right? So vitamin D is actually necessary for bone health because of that intimate relationship with calcium absorption. So if you don't have enough vitamin D, you could potentially have bad bones. There's other things that vitamin D is important on, and there's a lot of research these days about people with low levels of vitamin D, how it might affect the cardiovascular system, and some other areas of health. But let's just focus in on calcium absorption, at least for this lesson. So when we're talking about vitamin D, necessary for calcium and bone health, well, we know that people who get little sunlight could potentially have low vitamin D levels. And what does that mean, little sunlight? Well, sometimes people who live in the extreme northern or southern portions of the globe, people who are in a consistently cloudy environment with little sunshine, people who don't go outside very much, could potentially have low vitamin D. And that's because the skin will absorb the sunshine, the ultraviolet radiation, to actually create vitamin D for your body to use. The other thing is, I have here, vitamin D deficiency can lead to these conditions: osteomalacia or rickets. Perhaps you may have heard this. This is not osteoporosis, this is osteomalacia. Osteomalacia is softening of the bones because you don't have sufficient calcium. That typically happens with adults. Similar condition can happen with children. That's called rickets. Insufficient vitamin D, either through insufficient production, insufficient dietary sources, some genetic issues as well. That can lead to potentially in children problems with their legs. They could have bowed legs for that. What does that mean by bowed legs? I'm talking about their legs may look like, sorry, let me get this thing right here, kind of look bowed like this, right? So here's the feet like that, and here's the body over here. Sorry, this is the that looks like the head. So this is the body, the legs kind of bow out like that. Bad drawing, my apologies. Okay, let's dive into this just a little bit deeper when we're talking about why the skin is important for vitamin D synthesis. So take a look at this. I have this kind of like highlighted out here, but I have a lot of acronyms and numbers and stuff. But take a look at this chart here. Okay, I got this from a website called uptodate.com. It's behind a paywall, so probably not very easily accessible for you. But I liked it because it has a nice simple flow that you don't see in, say, like in your textbook. Your textbook doesn't show this. But anyway, so we have at your epidermis, because this is where we're talking about integumentary. At the epidermis, ultraviolet light will create this substance called cholecalciferol. Sometimes that's called vitamin D3. D3. Cholecalciferol is kind of the longer word for that. Vitamin D3. And here is this thing right here, right? So there is a precursor in your skin and that's called 7-dehydrocholesterol. So that's cholesterol type substance. Remember, that's a lipid. Right, so that lipid, that cholesterol substance, gets converted through the action of ultraviolet light in your epidermis to cholecalciferol, or vitamin D3. That is the process here that happens in the skin. You don't need to know more than that. You don't need to know the whole chemical reaction and all this. I think that's not necessary um, for what we need to do. Just know that sunlight will convert this precursor into vitamin D3. Where else can you get vitamin D3? You can get it through your diet or through supplementation. There's very few foods that actually have natural vitamin D3 or cholecalciferol in them. But there are lots of supplements out there that will do that for you. Like, say, for example, you've heard about dairy products or supplementing with vitamin D and calcium. But you can actually buy supplement pills, right, that are vitamin D3. Right? So you get this vitamin D3, you take it, you eat it, you consume it, whatever. Or you can have this other one here, vitamin D2. Don't worry about that for this discussion. But vitamin D3 is then taken to the liver, whether it's by the diet or not. And then it's taken to the liver, and then it gets converted into this one thing called calcidiol, 25-hydroxy vitamin D. That's shortened by this 25-OH. OH means hydroxy. So 25-hydroxy vitamin D is created in the liver. Okay, it's converted from this precursor, vitamin D3. That's also called calcidiol. That then goes to the kidneys for the next step in conversion. So it goes from vitamin D3 to 25-hydroxy vitamin D, and then in the kidney it gets converted into this thing called calcitriol. So you have calcidiol, and then you get calcitriol. Notice that di means 2 and tri means 3. And these numbers, 125 dihydroxy, that's more for chemistry. So don't worry about that for this course. You don't need to know like 25 or 125. I'm not going to test you on that. What I want you to know, though, is the process that it goes from the skin to the liver to the kidney to be the active form of vitamin D of what your body actually uses. Okay, so it isn't quite accurate to say that the skin makes vitamin D. It's more accurate to say that the skin will create a precursor to vitamin D, specifically 125-dihydroxy vitamin D, or calcitriol, based on a conversion from this substance here, this cholesterol substance, through the action of ultraviolet light. It was a long time it took just to say that, but I think this is important, not just for this portion of the course, but when we get later on in this course, when we're talking about calcium regulation, bone health, bone growth, bone loss, that sort of thing. So this is a very, very important step that I want you to know, because this is going to be coming back. We're going to be talking about this again here in a couple weeks. Okay, next slide. So enough of those functions. Let's talk a little bit more about skin tone or skin color. Okay, so we mentioned before about this substance called melanin. Melanin is a substance that's made from tyrosine. Remember, tyrosine is one of those amino acids we talked about. It has some modifications to it as well till you get this substance called melanin. So melanin, we had mentioned, is primarily responsible for the color of your skin. Not the number of melanocytes, but because of the type of melanin and the amount of melanin that's being produced. Okay. There are other things that can contribute to your skin color. For example, hemoglobin. Hemoglobin is the oxygen-carrying molecule in your blood that has a certain purpose. It carries oxygen, but when it does so, it turns the blood into kind of more of a bright red color. So hemoglobin is that molecule, that substance responsible for the color of blood being red. How do you relate that to skin tone? Well, in folks like me, I have relatively pale skin, light skin. So hemoglobin in me will have a greater effect on my skin tone compared to, say, somebody who has a much darker skin, because you can't really see um, the blood flow underneath that skin, except maybe in certain parts of the body. Another thing that is responsible for skin tone is the substance called keratin. It's very, very minor. It can add a little bit of a yellow-orange tint to your body. So if you eat an overabundance of keratin, whether that maybe like eat a whole bunch of carrots, it has that potential of kind of turning your skin a little bit of an orange color, because it can accumulate in the stratum corneum of your epidermis. So eat carrots, but don't eat too many carrots, right? So back to melanin. I mentioned that melanin is made from an amino acid called tyrosine. Um, there's different types of melanin out there. So sometimes it can be a red yellow color or a brown black color. Everybody's a little bit different in terms of the melanin that's being produced. That's genetically determined. Synthesis of melanin in the melanocyte, remember those melanocytes, they're at the basal layer of your epidermis, requires a specific enzyme called tyrosinase. Remember, ASE means it's an enzyme. So just a little bit of a fun fact there for you. Tyrosinase, necessary for melanocyte production of melanin. We had mentioned before, melanin blocks the harmful effects of ultraviolet radiation. And because of that, when you're looking at skin tones in general, right? So populations who originate near the equator tend to have a much darker skin compared to those distant from the equator. That kind of makes sense, right? So imagine on the globe, the equatorial regions, the populations that originate there. Compare that to folks who maybe are from the far north of Europe, um, uh, differing in their skin tones. Part of that is just because of, over time, these populations in the equatorial regions tended to get more darker skin because that melanin was provided a survival benefit, if you will, right? So the darker skin tones had, those with a darker skin tone had beneficial effects in terms of survival from ultraviolet radiation. Those up in the far north of Europe and such, maybe not quite so important. Okay, I think this is almost review. We already talked about these things. So melanocytes, they're in the stratum basal. Um, Humans essentially have about the same number of melanocytes. I mean, it's not precisely the same number, but you get the idea. It's not the number of melanocytes that determines skin tone. It's the type and amount of melanin, that's not only made but also retained. So what does that mean? Well, sometimes if you have exposure to ultraviolet radiation, that will stimulate melanocytes to secrete melanin. Some folks get a nice tan in the process, right? So when you talk about laying out in the sun, getting a little sunshine, your skin will darken a little bit depending on your skin tone, of course. You would tend to tan. Folks like me with fair skin and red hair, we don't tan, we burn. So just kind of so some folks will tan, others won't. But the tanning process is temporary, right? So that's what I mean by retained. So you go out and get a tan, it lasts for a while, but then it starts to fade away. And then as you have less sun exposure, your skin becomes more and more pale, more and more pale. You might also see that phenomenon in something called a farmer's tan, right? So somebody who's wearing a t-shirt outside, their arms and their head and neck might be a dark color, but because they're always working outside but wearing a t-shirt, their chest and their upper arm might be very, very pale. The other thing about the effects of melanin, the effects of ultraviolet radiation on the skin and melanin production, think about freckles. So here's an image of fair skin with various freckles. You can kind of see the pale skin around there, and then kind of the orangish spots or splotches. These are freckles. Okay. What are freckles? They are a localized collection of melanin. So it's a different type of melanin. So the folks who will freckle produce a different type of melanin compared to those who don't, right? So what does this mean? Well, this means that if you know somebody who has freckles or you have freckles yourself, you know that you get more freckles the longer you're exposed to the sunshine. So children generally don't have freckles. It's just the more they're outside, they'll start to freckle more and more and more um, as the longer that they have exposure to the UV radiation of the sun. So this is, again, a bit of a protective mechanism. I had talked before about how the melanin can protect the cells against UV radiation. So the longer you're out in the sun, the more freckles you get. Sometimes those freckles will even, like if you see up in this zone over here, they start to coalesce compared to over here. So if you know somebody with freckles, you'll know that most of the freckles are in the zone that's most exposed to sunshine, like say the face and neck and arms, but maybe not so much in zones where clothing is normally worn. Another thing about localized collection of melanin is something called a mole, right? The fancy term for that is nevus. I think most people know what a mole is or have seen it, know people that have it, or you have some yourself. What is a mole? Well, it's a localized cluster of melanocytes in the skin. Right, so here's an image of it right here. Now, before I had mentioned that, your skin tone is not determined by the number of melanocytes, which it's not, but these other things right here, like a mole, you can have a cluster of cells here, and what they do is they produce a certain type of melanin, an abundant amount, that gives that mole that particular shape, size, color, and so on. Those particular cluster of melanocytes are called nevus cells. Now these moles here most often are benign, but there are times when you have a overreaction of melanocytes that can create a skin cancer called melanoma. We'll reserve that for a future lesson. All right, so those are kind of normal skin tones, normal skin colors. There are times when skin colors can change, and that might be an indicator of an abnormality. So here's the first example, something called cyanosis. Do I want you to know these names? Actually, yes. Why do I want you to know these names and these terms? You're going to see them again. You're going to see them again in this course. You're going to see them in future courses, whether you are pre-nursing or if you're doing other types of kinesiology, you may see some of these conditions, or at least as you're evaluating patients or folks with whatever condition, you may be recognizing things like this. Okay, so this is very important. So I do want you to know these. Cyanosis. So cyanosis is an abnormal blue coloration of the skin. Typically it's due to low amounts of oxygen. So previously I had mentioned about how hemoglobin has that kind of that reddish color to it because of the oxygen that binds to the hemoglobin molecules in the blood cells. Well, if you have poor oxygenation, the end result is that the skin tone will appear blue. Oftentimes it occurs in the fingertips, like in this example here. It can also occur around the lips on the face, right? So you can have a little bit of blue discoloration due to insufficient oxygen in your blood. Next up, you can have something called pallor. Pallor is a condition of pale skin. That's because of diversion of blood away from the skin. Now remember before, earlier on, I talked about shunting of blood away from the skin surface to save body heat. Well, there are other times when you can have diversion of blood from the skin. So for example, if you have massive blood loss, hemorrhage, um, that blood needs to stay in the body's core so that the brain and the heart and the kidneys and other essential organs can survive. So as a result, your skin can appear pale. You could also see it, you can see this person here is pulling down their eyelid. This little zone underneath the eye, right here, that could become pale as well. So that's one way to kind of, get an assessment of somebody's skin pallor. Another way that people might call that is being white as a sheet or white as a ghost, right? So if somebody say is passed out, they get really, really pale. Here's another color. The color is yellow, and that's technically called jaundice. So I don't know if you can kind of sense compared to that previous image, but this person here, his face is very, very yellow. It's jaundiced. And that is due to an accumulation of a substance called bilirubin. Bilirubin is something we'll talk about in the digestive system next semester. But what do I want you to know? Well, you might have a condition of jaundice when somebody has liver damage. Okay, so perhaps you've heard of something called hepatitis. If their liver is severely damaged, your body is not able to process bilirubin effectively. So the bilirubin goes where? It just kind of gets deposited in the skin. There's a whole process of kind of, really diving deep into the types of bilirubin and that sort of thing. We don't need to worry about that. What I want you to know is that if somebody's skin is yellow or jaundiced, typically it's because of some sort of liver damage that's causing that. It could be other things, but right now just focus in on the very common and basic one, which is liver damage. As with pallor, you could also see this in the eyes. So I didn't get a picture, but if you were to pull open his eye and take a look at the whites of his eyes, you would see that they're actually yellow. So that jaundice can also deposit in the eyes, turn them into yellow eyes. Next up is erythema. Erythema means red or condition of red. So if you say that somebody's skin has erythema or is erythematous, I'm sorry, erythematous, I said it wrong, that can indicate a number of things. It could be maybe they have an infection, maybe they're really, really hot. Remember we talked about that shunting of blood to the skin that can cause some erythema. If somebody has a mild burn to their skin, like a sunburn, it can be red. It could be other things as well. This particular diagram here is from a condition called erythema infectiosum, or fifth disease. You don't need to know that, but it's just a condition where, especially in children, you have this characteristic appearance of the cheeks being red like this. It's called the slapped cheek disease, as if somebody had slapped the child on the cheek. But of course they didn't. It's because of the particular virus that caused this infection. Next up, ecchymosis. I think everybody has experienced this at least once in their life. It's a discoloration of the skin due to a collection of blood. Actually, I think it kind of goes around this way a little bit here too. Right, ecchymosis. So it's a discoloration of the skin due to collection of blood. A more severe form of that might be considered a bruise or even something like a hematoma. But if it's just a simple discoloration of the skin, right, so like in this particular example here, perhaps they were hit, and so maybe this is maybe more of a hematoma. But if you had just a collection of blood, it's not very tender, not very swollen, you may just call it ecchymosis. And it could be various colors, sometimes red, purple, these dark colors. Over time, what ends up happening is this blood gets reabsorbed, and you can have kind of maybe some yellowish green tint remaining towards the end. And that's one way that's in the field of forensics, you can age how long a bruise has been there, right? So if it's really fresh, it was really maybe these dark colors here, but if there's like mostly yellow and green colors, that means that that ecchymosis or bruise is maybe a few days old. And finally, we're going to talk about this last one called acanthosis nigricans. It's a big fancy word. What that means is just kind of just dark pigmentation in certain skin folds, right? So this one is under the arm. You could also have it around the neck. It kind of has this dark appearance to it. It's not because the person has bad hygiene or they use a particular type of deodorant, but something like this is an indicator of something called insulin resistance. Uh, we'll get into that later in this course about glucose control, but when you think insulin resistance, think of things like diabetes or high blood sugar levels. So this could be an indicator of somebody who has some sort of insulin resistance in their body from other things. Also notice here these striae. Remember we talked about stretch marks? Here's some striae come along the skin there as well. Okay, all right, that was a relatively long video for me, my apologies, but hope you found it insightful, and we'll see you for the next one.